Hello, hello. Hi. Can everyone hear me? Okay, cool. All right, great. Hi, everybody. My name is Jasmine, as Troy said. I am a developer at GitHub, and I'm here to chat with you about some UI automation stuff that the editor tools team has been doing at GitHub. So the editor tools team is a team of five of us who basically take your GitHub workflow and put it into your favorite IDE or text editor. Right now, that is GitHub for Visual Studio and GitHub for Unity. So, and they're both open source, and I will have links for you all to check them out later at the end. I am known as Paladik on GitHub and just internet in general. So, yeah. All right. So, let's get started. So we all think we're pretty clever, pretty good. We're being good developers when we add unit and integration tests, and we also do peer reviews, right? You could say it's a form of testing. You're having somebody come behind you and look at your code and make sure it's right. And the whole goal is just to make sure that what we're building is right? So when we've built our unit tests, we built the code, we've built the thing we wanted to build. We have our unit integration tests, and then when we debug, we kind of try it out manually. Click a few things, and make sure it looks good and looks right. So there's a few reasons. There's many, but here's a few reasons why we manual test. We're fixing a bug. We're hunting it down. We're trying to look at where is this bug? Replicating steps. Somebody gives you a screenshot, and you try to get to a certain state and see what's going on. And then when you fix it, you try and replicate those steps again and make sure that the bug is gone. Now, when you're adding a new feature, you want to make sure that what you're building actually works. And then when you are getting to cut a new release, you want to make sure that all the bugs that you fixed and all the features that you added are actually there, right? So how extensive is that manual testing? The three scenarios that I just gave you, the thing that's the common thing between all of them is that you have a laser-focused goal in mind when you're testing, when you're manually testing. You're just looking at, you just want to see the thing to make sure the thing is actually broken, or it works, or that's the main thing. So it's super easy to find, to not notice a regressive bug or something silly or wonky going on in your code or in your UI. And this is the problem that the editor tools team faced. And I'm going to show you some examples of that. So this first one here, we were working on the main. Oh, by the way, like I said, we're open source, so you can see all of these issues and PRs that we've made. So this example here, we're working on the maintainer workflow, which is basically a feature set of being able to list pull requests, open pull requests, and view discussions on them. And then right now, inline comments are a thing that we're working on now. And so I believe we were just like testing and just like poking around, and we came across this debug asserts line of code. And of course, okay, so right, it only shows up when you're debugging, but at the end of the day, it's like not supposed to happen. That's why why it's there, right? So the point of this is that we have been debugging. We all run Visual Studio every day. It's our job, and we never came across this debug asserts. And maybe this code has probably had been in production for like a few months. Next example I'm going to show you is mine. So I added some stuff that I literally added just one an ID property. And so I'm like, okay, it builds, it opens, it runs. Okay, the test passed, seems fine. So when we finally were about to cut a new release, somebody was manually testing and noticed that the private repository checkbox was all weird. And I didn't, and I was like, oh no, oopsies. And so I looked through my code, and yeah, it was me. And I fixed it, and it was fine. So the obvious solution for us is to get a QA tester, right? So the only issue is that there's not many people at GitHub who write C# all day and who work in a Windows environment. So it takes a long time to train somebody. And on top of that, when we had a QA engineer, their responsibilities were split up between our team and other teams. And so sometimes we can't always get the full support that we want. So we had actually, our last QA engineer built an automation framework, I believe with Java, and gave us some really cool ideas in terms of automation and how to integrate it into our testing and our quality process. And it ended up that we needed some more manual testing support at the time, because it was a cool idea. It was just wasn't for us at the time. And so eventually the project got scrapped, and the QA engineer eventually moved on to another team, and so we were left without a quality engineer. So our technical project manager at the time, who was Sarah Ford, introduced us to CodeUI. And she gave us a demo project, and we were playing around with it, and we're like, oh, it's cool, let's try our own framework and see how it goes. And so that's how our foray into automated testing and CodeUI started. So Microsoft introduced CodeUI into Visual Studio Enterprise, and the tools built into VS for tests driven through the user interface. It supports WinForms, WPF, Windows Phone, and Store apps, and you basically have two options on how to use it. You could either do a recording where you basically press the record button and you open up your app or whatnot, and you click, do all the steps, get to a certain state, and then you press that assertion button, and it adds an assertion for you, and then when you're done recording, it generates all your code, and you can play it back and let it do its thing. Or you can hand code your own framework and with CodeUI's library. And that's what we did. And the main reason we did that is because there's lots of parts in our extension, and we wanted a little bit more control and flexibility on how to use the framework and how to run tests. So that's what we did. So the way we did this was with the page object model. So normally this is familiar, or you'll hear it. It's a familiar term in when you're using Selenium, which is another automated system or framework for but it's specifically for web, where you basically you encapsulate all of the access and mutation or modifications to a not a WPF, but just some kind of element, some kind of control, for example, a text box. And in terms of modifying, I mean typing in something. And you encapsulate that, and you make functions that are actions. So, for example, typing in the text box would be an action. That would be a method, and that would be my action. So, eventually those actions would lead to assertions in your test, and you make sure that whatever you're trying to do, whether it's you're filling out a text box, you make sure that a button is enabled when you fill out a text box, and making sure that it passes. So, and again, that's basically what this element is, or sorry, not this element, but this diagram is doing. It's basically saying, don't let test methods exactly take or alter any of the access or alter any of the controls in here. Do it through the API. So, and this is how we implemented it. So, in this top code right here, this is a test case, and so we launched Visual Studio. So basically, what this test is doing is. Oh, wow, that's weird. That was a thumbs up emoji, and down there, I don't know what happened. Anyway, so the test case is pull request count matches.com. And basically what we're doing here is making sure that I'm taking like a random, well not random, but a test repo, and I'm opening it up in Team Explorer, and then I'm going into our GitHub extension and making sure that it has 0 pull requests. And so if I run this test case, it'll open the repository, it'll open the GitHub pane, and then it ends right there at the pull request list, and then it counts up how many there are, which should be really quick because there's none, and the test will pass. And this is what the UI looks like, and so if it looks like that, it should pass, right? So the thing about CodeUI is that you kind of need to, when you're searching for controls, you kind of need to tell it be very specific in what you want, because sometimes it might return things that you don't want. So in this example here, I'm making a button, and I'm saying, okay, I have a button that has a name of cancel, a control type of button, and it has a specific automation ID, which I'll get into a little bit later. So the way that CodeUI searches for these controls is with the breadth first search algorithm, and not to get too into it, but basically with those search properties, CodeUI finds all the controls that matches the properties. And if it doesn't find any, it'll find controls that match some of the properties. And if it doesn't find any of that, it'll throw an exception. Now, in the case that it does, it'll return the control that is closest to the parent control. So in breadth first search, you're supposed to find. You have to give a source vertex, which is basically the parent, and in CodeUI case would be the parent control of the control you're looking for. So if I'm in a panel, I want to find a button in that panel. If it's a text box, I want to find a text box in that panel, and so on and so forth. So going back to this slide here, that it's not in order, but so the way that CodeUI executes the find function is it happens after when you're doing an action, which might not be the best time, because it might, if the control's not found, it's gonna blow up in your test, and your test is gonna fail anyway. But it's better to do it before you start doing actions on it. You don't want any unintended surprises, right? So we have this. There's this extension method that we built called ensure. And so what ensure is doing is it's accessing some WPF-specific properties and looking, and which exists and enabled, and checking and seeing if it's there and it's enabled, and if it's not, it throws a custom exception. So it's better to do it here than having a CodeUI tell you, and like waiting for it to tell you, oh wait, no, actually I can't find this, sorry. So the way that we built our tests is we have this list. We call it the test manifest, and it's just this huge long list of manual steps to test when you're doing a release, or you're just testing master and making sure it looks good. So we take those manual steps and turn those into test cases. So this specific one here, it's, when you make a pull request, the branches, your target branch and your source branch can't be the same, right? So this test is making sure that when you get to the create pull request pane or view, you switch the branches to be the same, and when you type in the title of the pull request, because that's all you really need to make a pull request, making sure that the create pull request button is not enabled, because you shouldn't be able to make a pull request when you have two branches that are the same. So I'm going to run a demo of how that works. So I'm going to, and So the way the framework works right now is that all the test cases are run through Test Explorer. I can't think of a better solution than that, but it works for now. So what's happening is it's launching Visual Studio with the extension installed, and the next thing it's going to do is it's going to open the Visual Studio, not the GitHub for Visual Studio extension in a second here. I put some stuff in here to make it a little faster. There we go. And it's opening our extension. And now it's going to try to make a new pull request. And if you give it a second, it'll get there. There we go. And now I'm on Paladeek testing branch, and it's going to switch to Paladeek testing branch. And we have an error there that tells you that you can't do it, but we got to make sure that the button tells you that you can't do it either. And I'm typing in title of the pull request, and the test passed. Yay. So, thank you. So the main reason to use CodeUI is for making sure that your UI looks good and that you're not picking up any regressive bugs, right? Well, here's some other things you can use it for. So so our team we have some internal usage metrics that we use, and if you do too, what do you do when you notice that somebody's using one feature significantly less than other features? You can use CodeUI to simulate how to get to that specific feature and see how many steps does it take? How long does it take someone to actually get here? And work on that. Now, what if the reason why people aren't getting to that feature is because it has a bug in it. And I know we've all experienced this where somebody will find a bug and not tell you, especially if there's a workaround, which is so annoying, right? And so you can have CodeUI actually just do it for you, okay? And so no one's using this feature, and let me see what's going on. You can tell CodeUI to take some screenshots for you and say, what does this look like what does my app look like when it's at this state? And the final one is documentation. Maybe this is not the best use, but you know what? Don't let people tell you how to live your life. So you can say, so you can have maybe you're building a new feature and you have to make some documentation on it. And so that's going to take a few screenshots, right? Well, you can tell CodeUI to go through steps and take those screenshots for you. So one of the biggest challenges, and so the main reason behind us trying out test automation is because our extension is, as far as I know right now, we're the only extension that ships with Visual Studio 2015, 2017, which means that we want to make sure that we don't crash Visual Studio, and we want to make sure that Visual Studio doesn't look ugly, that we don't step on any toes, right? So it's really critical. And the other part of that is that we've integrated ourselves into Team Explorer, and we also want to, where Visual Studio Team Services also live. So we don't want to step on any toes at all, right? Because they're technically a competitor, right? So we have a few things that we want to continue to add on in our test automation. So mostly, for things like chat commands, being able to fire off some tests or a subset of tests, having actually integrated in a release process, maybe when we cut a release, automating installing a new version extension and running through test cases. Making sure that QA can actually write their own test cases, making sure that it's clear enough for them to understand how to write their own test cases, and we would supply the backend or the framework if there's a feature that hasn't been automated yet. Making sure it's open source so that anybody who else is interested in it can check it out and help out. And also keep steady coverage at 90%. So basically, going from oldest features to newest features. So maybe we don't have time to automate the newest feature, but we want to make sure all the other ones haven't regressed. And then also just having a dedicated virtual machine who can just run this thing whenever we tell it to. So basically, right now we are at our 60% of our extension is automated through CodeUI, and like I said, we eventually hope to have at least 90%. And we hope that we can finally make it open source. When we finally make it open source, that it's just a good reference point for those who are looking to try out CodeUI, and for those who just want to play around and help contribute. So CodeUI might not be for you, might not be for everybody, and you might not even need it. But if you do, or if you're interested on how we've done it, please check it out when it's public. And in the meantime, check out the GitHub for Visual Studio repo and the Unity repos. They're both open source. And you can find me at, like I said in the beginning, you can find me at Paladik. My talk transcript will be up a little later today. Also, link for GitHub for Visual Studio and Unity. Check us out. Thank you.